All right, hello, and now we're doing Content Standard 54, solving applications. Sorry, I'm trying to make sure I get the whole problem in here. There we go. Oh no! Okay, all set. All right, so these are the application problems, and it's like the plane is flying, and we're just gonna go ahead and get it started. We're gonna be looking at finding the how far it'll go after so many hours, and we're gonna hopefully find the resultant direction as well. So part one is a plane is flying 230 miles per hour at a course that is 48 degrees east, east of north. So first, it's good to know your east of north. The way I used to remember as a kid is I would have never eat soggy waffles, right? And you can just kind of have that for yourself if you need it, but just make sure you know. So east of north is this. So we start east and then we go north. So it's gonna be a angle going up this direction. North of east would be north then east, right? So what we're going to do is we're going to start us off. We're gonna give ourselves a little grid. And we are going 48 degrees, so that's roughly 45. I'm just going to kind of go. And we are going 230 miles per hour. Right? All right, so now it's assisted by a 100 mile per hour wind going 41 degrees east of north. So there is another guy, and I put another grid like this so I know, like, hey, east of north. So east of north. So we're going 41 degrees east of north, less than 45. And this is 100 miles per hour. And now our goal is to find this resultant vector. And we are going to eventually, like I said, find this angle of the resultant vector. And yeah, it's going to be a whole nice little deal. Now, to find this, it's going to involve a little bit of sine and cosine, primarily cosine. And we are going to be using cosine because what we want to do is we want to find the full horizontal distance here and the full vertical distance here. And to find the full horizontal distance, what you're going to do is we have this little tiny triangle here. And we're going to find this horizontal distance, add it to this horizontal distance from this triangle, which is why we have to do sine, cosine, and tangent, right? So we know that this angle here is 48 degrees. We know this angle here is 41 degrees. So what we could do is to find the horizontal here, we're going to do, I'm going to kind of skip, but I'll set it up first, but I'm going to start skipping into ahead. So what we're going to do is we're going to do cosine of 48 degrees. And that is going to equal our adjacent over our hypotenuse. And again, we don't know our adjacent, and I'll just call it x1. And that's what we want to find. So it's going to be x1 over our 230, which we're going to then change into a multiplication of 230 times cosine of 48 degrees. And what we're going to be doing is we're going to add the other one, and I'm just going to kind of skip, and it's going to be 100 times cosine of 41 degrees. Right, so that's what the other one is going to be for that guy. And then to find the vertical distance, we're going to instead do the sine of that, right? So instead, I'm going to do, it's pretty much the exact same thing, but I'm going to replace cosine with sine. So I'm just going to, and I just find this easier to think about. I know setting it up and going through the process each time is a good habit. But if you just think about, like, hey, to find the vertical, just do cosine. To find the horizontal, just do sine. You're adding them both. You're going to do both of these. It doesn't matter which order you do this in. You just want to get it done, right? And this is pretty much the same. Well, I guess if they're both going the same direction, east of north, this is pretty much how it works. Like if they're going opposite directions, it's a little bit different, but it's not too bad. Also, I just realized I put not sine. No, I need to put sine here. Whoops. The S here messed me up. Okay, so now let's just plug this in our calculator and then we're done. Our calculator is here. Okay, so it's 230 cosine of 230 times cosine of 48. Okay, and then we're gonna add. Actually, let's just write this down. I don't trust this new calculator over here. I'm just gonna write it down. It's gonna be 153.9. Oh, perfect. Okay, so let's do that. All right, and then we're gonna do. While we're here, I'm just gonna find the sine version equivalent as well. It'll be faster. Sine of this instead. Oh, that's my cat. Okay, sine's gonna be 170.92333. Okay, 0.923. We'll do that, and you're going to add them to 100 sine of 41, which is going to be 65.605. And again, those get added to equal. Oh, I'll add them a bit. And then the last one is going to be 100 cosine 41. Which is 75.471 if you round the 09. Alright, so now let's go ahead and add these. 153. Oh, gotta clear the space below. Okay. 153.9 plus 75.471. And that will equal 229.371. And then we're going to do 170.923 plus 65 point 605, and we get 236.528. Oh, hi. Alright, well, my cat, oh no, my cat has joined. Sorry about that. And with that, we now have our resultant. So our horizontal, we're going to write this down. It's going to be 229.371, comma 236. Oh no, please go be free. Sorry about that. 236.528. Okay. So, and now that we have that, you're probably thinking, wow, that must be it, right? No, it is not. What we're going to now do is we need to find the total mile per hour. So we need to find this diagonal distance. And I'm sure you guys already know how to do that. We're pretty much going to be doing, well, you really can just do Pythagorean theorem at this point, to find this diagonal distance. So that's actually what we're going to do so we can find the miles per hour. So another way I guess you could do this is you could just do, no, we already know we'll have to do tangent inverse in a bit. Okay, hi cat. So let me go ahead and do this. So what I'm going to be doing is, now that I have this distance is 229.371, and this distance is, oh my god, hi cat. Sorry about this. 236.528. Just gonna put that there. 0.52. That looks like squared. Oh my gosh. All right. Either way, so we have that distance. We're gonna go ahead and do 229.371 squared plus 236.528 squared. And by the way, if you were moving ahead, we're just going to do tangent inverse to find that the resultant direction. But we're going to do this. Let me plug this into the calculator. 236.528 squared. And then, okay, it's going to be 229.371 squared. No. Yeah. Online calculators do not work well. Let's just shift. Okay. So we get 1,000. Oh no, it's not 1,000. So much more. 108,000. 556. 0.550. Okay. Now we're gonna take the square root of that. Now. 0.55, and that is going to give us 329.48 miles per hour. So now if we want to actually answer the question, which is it says for 2.3 miles, 2.3 hours, how far will we have traveled? We're just going to multiply our 3.29 here. We're going to go ahead and multiply that by 2.3. And we will get the answer 757.8 miles. And then, when they're like, hey, what's the direction? Well, they want to know what this angle is here. And now we're going to go ahead and just do our tangent inverse. And we already know our vertical and horizontal. So we're going to go ahead and do tangent inverse of our vertical over horizontal, opposite over adjacent again. I just do vertical over horizontal for my own brain, I guess. And that's going to be 236.528 over 229.371. Cat's being a little gremlin right now. So let's go plug that in now. Two 336.528 divided by 229.371. I mean, yeah, they are pretty close to numbers. We get almost a 45-degree angle here. We get 45.88 degrees. Yeah, they're pretty close. That makes sense. All right. And that is how we would find the resultant direction of the plane's travel and overall how far the plane would have traveled. And I guess if the question would have asked, because it could have just asked, the overall magnitude of which the plane was traveling. So any of those questions that would have been asked, this is how you would have solved them. If you have any questions, please come to room E203.